Welcome to The Explainer. Today, we're diving into a really fascinating research paper that could totally change the way our data gets processed. And, get this, it involves some pretty surprising technology you might not expect.
So let's start with a feeling we've all had. You know that split-second lag when you're using an app or playing a game or just waiting for a smart device to do its thing? It's that frustrating little pause between when you do something and when it actually happens. So why does that happen? All right, so here's our game plan. First, we're going to look at the problem with the cloud itself. Then, we'll introduce a new idea called fog computing and unpack the huge puzzle it creates. After that, this is the cool part, we'll look at a high-flying solution, and finally, we'll check out the data and see what it all means for our future.
Okay, first things first. We have to understand the fundamental challenge with how the cloud works right now. Because it turns out, even in our super digital world, distance still really matters.
So here's the crucial thing to get. When you use an app, your data often has to travel hundreds, sometimes thousands of miles to a massive data center, and then all the way back. And even traveling at the speed of light, that trip takes time. We call that delay latency. And for all the next-gen tech we hear about, like the Internet of Things or super-fast 5G, that delay is an absolute deal-breaker. So if latency is the big roadblock, and the cloud is just too far away to fix it, what do? What's the alternative? Let's move on and see how a completely new approach could solve this very problem. The answer people are exploring is this concept called fog computing. Now, it's not about replacing the cloud, not at all. It's about working with it. The big idea is to bring some of that computing power and storage way closer to where you and I are actually creating and using data. And this slide, it just lays out the difference perfectly, right? Cloud computing is centralized, it's remote, and that means high latency. Fog computing is the total opposite. It's decentralized, it's right there near the users, and it is built from the ground up for low latency. Here's a super simple way to picture it. Think of the cloud as a gigantic central warehouse for some national company. Yeah, it has everything, but it's way out in the middle of nowhere. Fog nodes, on the other hand, are like your local convenience stores. They're right around the corner, they might not have everything in the world, but they have exactly what you need, right now with basically zero waiting. But, and you knew there was a but coming, this brilliant solution of building these little data convenience stores creates its own incredibly complex and, incredibly expensive puzzle to solve. And this right here, this is the core question from the actual research we're talking about. This is the billion-dollar question. It's not just about building these fog nodes. It's about where on earth do you put them when the people who need them are always on the move.
And that is the real challenge, isn't it? Think about a huge concert, a festival, or a big sports game. For a few hours, the data demand in that one little area just goes through the roof. But the next day, it's a ghost town. A fixed server built to handle that peak would just be sitting there doing nothing most of the time, which is just a huge waste of money. This is where the research gets really creative. It asks a simple but brilliant question. If the demand moves around, why can't the infrastructure move with it? And there it is, the big idea. What if you put these mini servers, these fog nodes, onto drones? So instead of a fixed network of data convenience stores, you create a flexible, flying fleet that can be sent wherever the demand spikes. You'd have a data processing network that adapts in real time. Now, to make this work, the researchers had to get practical and model the drone's behavior. So they broke it down into these 4 key states, and each one has a different energy cost. But look at that last one, flying. That is the real energy hog. Just getting the drone to where it needs to be is the biggest drain on its battery, by far. So this all sounds great, kind of like science fiction, right? But is it actually practical? Does the math even work out? Well, let's take a look at what the simulations showed. Okay, so in this first scenario, think of this as a hypothetical future where a drone carrying a server costs the exact same as a regular fixed server on the ground. The results here are pretty dramatic. The simulations show that it would make sense for over 80% of the infrastructure to be mobile, replacing a massive number of fixed servers with these adaptable UAVs. But here comes the reality check. When a UAV is 4 times more expensive than a fixed server, which is a lot closer to today's actual costs, that economic advantage just disappears. Poof. It's simply not cost-effective to use them, and the best solution is to stick with the traditional, fixed servers. So right now, cost is the biggest barrier. And this is brilliant because it shows that the type of drone you use really matters too. You've got your rotary-wing drones, the quadcopters we see all the time. They're amazing because they can just hover in one spot, which gives you a super stable connection. But then you have fixed-wing drones. They look more like little airplanes, and they can stay in the air for much longer, making them better for covering really wide areas.
Now, this is a fascinating find, and it actually applies even if you don't use drones. The research showed that if you're willing to accept a tiny, tiny 5% drop in the amount of data you process during those absolute peak moments, you could save 30% on infrastructure costs. It's because you don't have to build out your system for that one crazy spike that might only last a few minutes. Okay, so let's pull this all together. Let's zoom out and look at why this research is so important for the world we're all building.
Look, this is not just some academic exercise. This is about laying the groundwork for a truly connected, truly responsive world. The ability to process massive amounts of data with almost zero delay is the critical backbone for so many future technologies. We're talking about the nervous system for smart cities, the instant decision-making for self-driving cars, and the data-heavy world of smart farming. All of it depends on a network like this.
What this research makes really clear is that using drones as flying data centers is technically possible. The biggest hurdle right now is just cost. So it leaves us with a final thought to chew on. As the price of this technology keeps dropping, it's really not a question of if our data infrastructure will take to the skies, but when.